Hello, today we're going to be taking this controller apart. This is a Hori Onyx PlayStation 4 controller, not to be confused with the Hori Onyx Plus, which has a headphone jack and can connect to the PC. So this is the older model, and as far as I can tell, it's no longer produced either. It's a third-party PlayStation 4 controller. It has 4 face buttons, a touchpad and button, the 2 main option buttons and the PlayStation button, which powers it on, the D-pad, 2 thumbsticks which click, and 2 shoulder buttons, 2 triggers, and that about does it for buttons. It has a similar stick and button layout to the Xbox controller series, which makes it nice if you want to try out PlayStation when you're used to playing Xbox controllers. Features it lacks compared to a standard PlayStation 4 controller is it has no audio jack, there's no speaker built in, the light bar is this little button instead, and there's no gyro, which is kind of a shame. So why am I taking this apart? Well, while this thing generally works, or looks like it works, and can even enter pairing mode if I hold this button for about 30 years, and then drop it, of course. It doesn't actually pair with the PlayStation anymore via USB or Bluetooth, and it doesn't pair with anything else anyway. So I'm going to try to turn it into a gamepad that works, with Windows probably. So let's open it up and see what's inside, right after I turn it back off. Okay. So, the controller has 7 screws in the back, 3 on either side, and 1 in the middle. There isn't one in the sticker, and you might be able to tell I've tried to check, but there is not one there, so you don't need to take the sticker off. The screwdriver I will use is this precision one I've got. It has tri-wing screws, similar to the ones Nintendo has, but a little bigger. And I have my trusty precision screwdriver here, and I found that the Y 3.0 bit seems to work the best. So I'll be using that. And I've got this little baggie to put all the screws and bits in as I go along. So let's start taking them out. There we go. Right, and with the screws all loosened, the back should just pop off very easily. There we go. Just going to put the screws safe in a bag in case they fall out. Okay, now I've removed the back and put the screw safe, we can move on to the next bit. Now we can see what we've got inside. We've got a battery, some trigger buttons, and some rumble motors. But I already opened this before and cut the motors loose because they were very in the way when I was inspecting the boards. So I'm just going to put them to one side too. Now we can take out the next bit, which is this black bit of plastic which holds basically the rest of the controller together. And that has just 2 more of the same screws from earlier. Well, I should point out that they're here and here. Should be that. And that should just pop out like so. And then you've got to, as you lift it, you've got to sort of fold it and then sort of twist the touchpad like that, otherwise it will get stuck and you might break it, which would not be good. So this is the remains of the front panel. We've got our contacts for buttons and our actual buttons and D-pads, which I'm going to put in the safety bag so we don't lose them. So now we'll probably want to take the board a little bit more apart, just to make things easier. There are essentially 2 rows of header pins connecting these back boards with this front board. So I'm going to separate them first, and that's as simple as holding black plastic and holding the front board and pulling. The battery is connected to the front board, so be careful not to pull that off. So the last bit we can actually take apart sensibly is the touchpad, which just has this little ribbon connector that connects the touchpad, I guess, to the main board, which just has these 2 black plastic tabs which you just push forwards and then you can slide it out. You can just slide it out. There we go. And that'll just reduce the risk of us breaking the cable. So now we have everything in individual components. We have the main board, the battery, and the touchpad, which I can't really use right now, so I'm going to go and put it with the other bits. We do have to be a bit careful because this battery is connected to the main board, so we have to be careful not to short anything as we mess with stuff. It does appear to have some sort of circuit in it. It could be a protection circuit, but I don't want to take the risk. So yeah, I obviously want to turn as much of this into a functional controller as possible, and the bits I can use are all the buttons, the shell, and this back panel. I can't use the front board because I don't know where the problem is and why it won't communicate properly. I can't really use the rumble motors either because there's not really a way for me to tell the controller to rumble through Windows unless I pretend this is an X input device, which I don't really want to do. So they'll go to one side. I can reuse the boards here because all the buttons work fine and the triggers work and the sticks work and click. The buttons all short to ground when pressed and have pull-up resistors on the main board, so I'll try to replicate that if I reuse them. And then the entire shell is reusable, so I'll try and use that too. As for how I reuse them, well, I'll need a new main board and something for the buttons to talk to. So for the buttons to talk to something like an Arduino Micro would come in handy if I want to have a nice wired controller. But I'll need, because the main board handles the D-pad and the 3 front-facing buttons, I will need a new main board which will have to look something like this for our PlayStation button, our options and share, and the D-pad, which I would use these tactile buttons for because I like a clicky D-pad, but I need a 3D printed bracket to sit under the D-pad because otherwise it allows you to press more than one button simultaneously on opposite sides, which is not so great. So that would be something I would change. I also want to re-add a gyro, like this MPU 6050, to see if I can add gyro controls to PC playing, which, since I've played Switch games, I quite like gyro aiming on a controller, so that's something I want to do. I want to replace these triggers because I hate how they feel. They feel really, really not good. So my options for that are I could use these little soft tack switches, which are quite comfortable and quite easy to press. I can use these clicky tack switches, which are nice and clicky. I can use this mechanical switch, which is a lot like the ones you get in a computer mouse, which feel quite nice and are essentially automatically spring-loaded, which is cool. Or I could keep them analog, which isn't really necessary, and use a Hall effect sensor in conjunction with a magnet, a lot like how the Xbox controller does it. And I can use springs like these pen springs if I want to keep the triggers bouncy. But the difficult part is how I'm actually going to connect to this board because they have these nice rows of headers, but as far as I can tell, they appear to be 1.27mm spacing, which I don't have. I only have big fat 2.54s, and I have nothing that really fits in them. My standard wire, my standard solid core wire, is too big to fit in the gaps. I have this slightly flexible wire, which does fit in the headers, but it's not great. See, I just bent the wire there. And even when you do get them in, they're quite loose and not a solid connection. So it's not really something I want to do. So I'll probably have to desolder these header pins and solder directly to the board with wires similar to these ones and connect them to a main board, which will then interface with an Arduino and presto, have a new controller working, hopefully. So that's essentially my plan for it. I'm going to use this bit, the shell, and remake a controller board, add a gyro, and interface it with an Arduino. Hopefully, I'll be able to build in Bluetooth again, and that'll need a battery, which will be an interesting one. And I also want to see if I can interface with this touchpad. I can grab the button quite easily, but I don't know how to actually communicate with it yet. But I have started to identify pins, which is nice. There's not a whole lot of information on the internet on how these touchpads work, so it'll be an interesting experiment. But yes, with that being said, that is the disassembly of the controller as far as it will go. And now I will start work on turning it into a functional one. So, thanks for watching. Okay, thanks, love you, bye.